Okay, today we are going to learn about subtopic 4.7, application of motion of charged particles. Application of motion of charged particles can be seen in the velocity selector in Bainbridge mass spectrometer. In the velocity selector, the velocity, the magnetic fields, and also the electric fields is always perpendicular to each other. In the velocity selector, it consists of two parallel plates, where the upper plate is positive and the lower plate is negative. So, the directions of the electric field is downward. At the same time, we have magnetic fields that is perpendicular with the electric fields. So, let's say we have positively charged particles enters the velocity selector. Okay, the direction of the velocity is always perpendicular with the electric fields and also the magnetic fields. So if the charged particles enters the velocity selector, the charged particle will experience two forces. One is the electric force and the other one is the magnetic force. So where are the direction of the two forces? So we know that the positively charged is always attract to the negative plates. So the directions of the electric force is downward. Okay, now where is the direction of magnetic force? By using right hand rules, we know that the direction of the magnetic force is upward. Okay, because the thumb represent the velocity of the charged particles. Okay, the rest of the finger will pointing into the page, follow the direction of the magnetic field, and your palm, okay, will show you the direction of the magnetic force. So the magnetic force is pointing upwards. So the direction of magnetic force is upward. So if we look here, the directions of magnetic force and the electric force is opposite to each other. Okay, let's say if the electric force is just balanced by the magnetic force, that means the charged particle will follow the straight line path. Okay, so the concept is, if the electric force is balanced with the magnetic force, mathematically we can write as electric force is equals to the magnetic force. Okay, we know electric force is equals to Q, the charge, times the electric fields, where magnetic force is depends on velocity, or the equation is charge times velocity times magnetic fields sine theta. So why is the theta is 90 degrees? Because theta is the angle between the velocity and also the magnetic fields. So the charge here, is it the same charge? We can cancel the charge and make your velocity as your subject. Then we get velocity is equals to E over B, where the velocity we also known as a selected velocity. That's why we call this is a velocity selector. So only the velocity that we want, that we have been set up, so all the charged particles that have the same velocity as E over B, that is going to go in a straight line. Okay, where the other charged particles that doesn't have the velocity or the selected velocity will deflect it. Okay, so only the charged particles with the velocity E over B will not deflect it. Okay, after the charged particles has moved inside the velocity selector and have the same velocity, E over B, the particles we go through the next chamber that only have a magnetic field only. So you have learned it before, where charged particles enters the magnetic fields, the charged particle will deflected or it will move in a circular path. So here, the charged particles with velocity v will deflected in a circular path. So according to the right hand rules, okay, if the charge is positive, that means the force will the charged particle will going or deflected upward. Okay, so you have learned in semester 1, okay, if the particle move in a circular path, they have centripetal force that is provided by the magnetic force, that because the magnetic force is always pointing to the center of the circular path. So mathematically we can write FB equals FC, okay, where FB is equals to QVB prime. Why is B prime? Okay, B prime is the magnetic field in the last chamber. Okay, so B prime, the last chamber magnetic field, is not the same with the magnetic field in the velocity selector. So that's why we put B prime here. Okay, same here, the theta is equals to 90 because the velocity and the magnetic field is 90 degrees perpendicular. Okay, so FC you have learned before this is equals to mv squared over r. Okay, so we know the velocity after the charged particle leave the velocity selector and enters the last chamber is the same. So the V is equals to E over B. Okay, you substitute V equals E over B into this equation, then you will get Q over M equals to E over R B times B prime. Okay, so what we can conclude here, and we can see through this equation, the greater the mass travel in path with the larger radius. Okay, the mass spectrometer can be used to separate ion according to their charge per mass ratio. So if the charged particle has a greater mass, that means it will deflected further. Okay, so here is the screen. So we can see which charged particles deflected bigger radius or smaller radius according to their masses. So that's why mass spectrometer can identify different isotope. Okay, thank you so much. Bye.